You didn't pick up my things.
Oh, I'm so sorry. I'm sorry.
These look brand new.
I don't know if they're brand new. I don't think they're brand new. They're just hardly used because most everybody just does like what we do. You know, they don't work out of the textbook. I mean, we kind of work out of the textbook, but we don't because I do everything for you guys.
Yeah.
Does that make sense? Okay, so, all right. So we're going to start doing this a little bit more often. When you guys first come in, you'll have a bell ringer. Okay, now, if I were to put the notes on this shelf right here, would you guys remember to pick them up when you come in first things? Would you guys remember? That way you can grab your notes and you can go ahead and get started on the bell ringer. And the bell ringer basically is just going to include, the bell ringer is just going to include basically vocabulary words of what we're going over that day, okay? Or it may be, I think, to help service you guys a little bit better, I may start putting some problems on there that are similar to like what we just went over on the day before that you might see on an ACT test. Is everybody clear on that? That way when you guys, if you go take that test, you're prepared to go do that. You're ready to go do that. All right? Now, page 3, I think it's 350 in your textbook. Send me on page 350. Is it 350? Is that the right one? Yeah, I see that one.
Chapter 8 starts on 532.
532.
Wait, 530.
530. I think it's 530, isn't it?
529.
Yeah. Okay, so on page 530, if you notice kind of like in the middle of the page right above it, that word is highlighted, right? Are you writing this?
I got you.
Okay, so that, if you look at that, that kind of gives you an illustration. All right, now go ahead and open up 350 so I can kind of walk you through this and explain it. Okay, when you see the term expression, now you won't have this, but this is in your textbook, and you may want to make a couple notes. When you hear the term expression, what does that mean? It looks like an equation, but it doesn't have what? It doesn't have an equal sign, does it? Who is it? Hannah? She's not here. Sorry. Okay, so it does not have an equal sign. So you're going to have some expressions like this, okay? And that means no equal sign. So you may want to jot that down. Now the reason why I want you to jot that down is if it has no equal sign and there's a variable in there, can I solve for the variable? No, I can't. So you may want to jot that down. This means cannot solve for variable. Okay? It's got to have, before I can solve for the variable, I've got to have an equal sign in there, right? Okay, so what does rational mean? That means fraction. Basically, rational means fraction. Okay, now, so if I can't solve these fractions, the only other thing I can do is what? Simplify. Good. Write that down. So when I simplify something, it basically means I'm just probably going to cancel a few things, right? See where there's some common on top to bottom. All right. If you notice in the example, this one right here, you guys have already done something similar to this. Okay? You guys probably did this in 5th grade, right? I'm tutoring a girl right now, she's in 5th grade. She's working on some of these right now. She has to simplify those. All right? Well, it's the same concept here. If you notice the x minus 1, I can cancel those two out on the top and the bottom. And then I just simply do what? Whatever's left over becomes my answer. Everybody see that? Okay, go to the next one, the next term, complex fractions. Okay, complex fraction basically is you have either in the denominator or in the numerator, you have a rational number, or you have another fraction on top of another number, or a fraction on top of a fraction. Okay, so jot this down, make a note of this. Do we divide in algebra? Do we divide?
Yes.
Shake your head no. We don't divide, we actually do what? We multiply by its reciprocal. Everybody understand that? So jot that down. Do we divide in algebra? The answer is no. We multiply by its reciprocal. Okay, now, is everybody familiar with cross simplification? Right. On the previous one that I showed you, you had the numerator over here and the denominator over here. Can I cross something now before I multiply it straight across, right? You guys remember that? So right here I have, what would I need to do on this first one to get what I wanted? Yeah, put that over 1, right? And then change it from C over 6 times 1 over 5D. Or, yeah. And then multiply it out. Okay, that's all you're doing right there. Does everybody understand? Okay. Go to your first example. Okay, now if you look at this, can you see some similarities or some things that are similar on the top and bottom that I can go ahead and cross out? Yeah, what's the same here? That one and that one are the same, so they're basically, if I take that one divided by the same thing, it ends up being 1. Good. So they essentially just cancel themselves out, more or less. Okay, so we always got to look for common factors. Once I find those common factors, okay, then I can eliminate from the top and the bottom, and then I simplify. Simplify basically means I'm just going to rewrite it. Okay? Just break down what I got left. Okay, now make a note. What is that right there?
Variable.
Yeah, but the whole thing. What's the whole thing here?
Square.
It's a binomial, right? What type of binomial is it? It's a perfect square, right? Okay, we say, what's between those two terms? A minus, right? So what's another term I can use for a minus? Starts with a D.
Divide.
Difference?
You
Divide is
said
not the same as
D. You
minus.
said D, so I was just.
Yeah, but it's the
Divide.
difference of squares. Okay? Now, what you have to understand, technically this may not be simplified. You understand what I'm saying? Okay? Because what happens here is I bring my 3y down. Well, this is really what? Plus minus, oops. Plus minus 3 and 3. That's technically what it is, isn't it? Okay, but I don't need to actually do this because what is my top?
3Y.
Yeah, it's just 3y. There's no minus or plus in between this 3 and this y right here, is there? So I can't cross anything else out, can I? All right, so what ends up being my answer here? That's as far as I can go. But you always got to make sure that you check.
Because there's no like terms.
Yeah.
Why?
If that were separated, and I'll show you an example here in a second, okay? If this were separated by a plus or a minus, then there's a strong possibility that we could cancel some more out, okay? I just got to make sure that we check and, okay? All right. So, all right. Second part of that, example 1b. There's going to be times where it's going to ask you to check for extraneous solutions, okay, or extraneous situations. What does that mean? Anytime you have a fraction, listen to me, anytime you have a fraction, you cannot divide by what? Zero. Right? You cannot divide by 0, right? Do you have a fraction here? Yeah, so if this bottom part right here equals 0, okay, there's going to be times when it's not going to work. So I got to find what numbers are extraneous here. What numbers will not work in that bottom part? Is everybody with me? Okay, so the denominator cannot equal 0. So I'm going to take this part right here, and I'm going to bring it over. Okay. And then I'm going to factor it. Now, this first part, do I need to factor it?
You said
It's already factored though. Okay, so I'm going to go y plus 7, and I'm going to set it equal to 0. Because it cannot equal what? 0. So what value can I plug in for y that's not going to work? Well, how do I solve this? Y cannot equal negative 7.
you can have a negative.
You have 0. If I say negative 7 plus 7, that equals what?
If you can't have 0, then why would you put it equal to 0?
Because it was switching signs.
Because I want to find out, I'm just isolating the y so I can find out what number I can use. Okay, yeah.
I'm confused why don't we just eliminate the y plus 7 like we did last time?
Because you have to check it. This is seeing.
But yeah, I'm not simplifying it. I'm just checking what numbers will not work. Okay, it's a difference. I'm not simplifying it. I'm just checking what numbers, if I plug in for y, will not work. You with me? Okay. So this one, I got to do what? Factor it. Now, it's a difference of what? Squares, so it's going to be real fast. Y, okay, plus, minus. What's square root of 9?
3.
3 there, 3 there. Now, I do the same thing. Y equals okay, so y cannot equal negative 7, it cannot equal negative 3, and it cannot equal 3. So those are my what? Extraneous. It means if I plug all those numbers back into this y, it's not going to work. Yeah.
So when you're looking for an answer to these other problems, do we have to write that first one we did and then those three?
Yeah. This one's already factored, right? So I don't have to do anything else. I'm going to have to factor this one. Okay? Now, if you just have a quadratic, you may just end up with what? How many binomials? 2 binomials.
So what it looks like to me is all we're doing is taking that 3, like those 7s they cancel out, and that 3,
Alright. Alright, so on this one, real quick. Okay, how do I simplify? Yeah, what do they have in common? Well, there's an x plus 5 there, and an x plus 5 there. Okay? What do I have left over? Okay, now, do I need to factor the bottom part? Think about it. If I factor the bottom part, I may end up with how many binomials? 2. Do I have a binomial on the top? Okay, so there's no sense in doing that, right? Because I'm not going to be able to cancel anything else out, am I? Okay, so this ends up being my answer here. And I can stop. Guys know what a binomial is, right? Okay, make sure. 2 terms separated by either, don't have to necessarily be in parentheses. Okay,
Oh, wait, I know what
is that a binomial?
you're
That's a monomial, right? Is that a binomial? Yeah. Okay. Be separated by either a plus or a minus. Okay, so on this one, okay, I just need to see which one, under what conditions, is undefined. All right? So I'm just going to take this and bring it out. I'm going to go ahead, set that equals 0, so x cannot equal -5. And then this one I'm going to have to do what first? Okay, it's a difference of squares. So my factoring becomes a lot easier, right? Okay, x plus minus 4, good. So x cannot equal -4, and it can't equal, okay, so these are my 3 answers right here. That's going to make it undefined.
So, all the questions on our assignment today be perfect squares.
No, I don't think so. Not all of them. Okay, but I think those should all be factorable. I don't think there's one in there that's prime. Okay? Only like 12 problems. Okay, look at this one real quick. This is one that you may see like on an ACT test. So how do you take what we've learned and apply it to this? Okay, so what values for P will make this undefined? So how do I solve it? What do we just do? Factor the denominator. Okay, now what type of polynomial is that? It's trie, isn't it? Okay, so the first thing I got to check is what? What's in front of the P? Is 1, good. Is it 1? Okay, then if it's 1, then I can just go ahead and start P right there, right off the bat. Everybody with me? Okay, then, now I'm going to have to come over and do a factor tree. What term goes here? C, right? What goes here? -2. Okay, so what are 2 numbers that I can multiply to get 15? 5 and -3. I can take those same 2 numbers and add them together to get what? Now, will those 2 work? Look at it.
5 plus -3 is 2, like positive 2.
So which one has to be negative now?
-5.
5's got to be negative, right? Now, would that make it true on both sides? Okay, so now, this is gonna be P, yeah, it's gonna be, I'll just take the -5, put it there. And this one is gonna be what? +3. Okay, then I just use my zero product property. Some of you guys will probably be able to get to a point where you use mental math, right? Just, you know, B can't be what? Can't be 5, and it can't be -3.
So, we're just trying to find out what it can't be.
Exactly.
Okay. That one.
Okay, because
Do they do that? Alright, let's go 10 years. My math's here. Let's say you're working for NASA and you're building a rocket. They got to do stuff like this to figure out what won't work so that thing don't blow up when they launch.
yeah, essentially, that's probably a little bit more advanced.
That's what I said. We're here, they're way up there.
But if you do this, how many of you scuba dive? Okay, so when you get to a certain depth, you can just go straight down and dive, right? Kind of, sort of, you gotta gradually work down. Why? Because you're in your ear because of the pressure, right? Okay, so if you get to a certain amount, a certain depth, okay, can you just like, okay, you can't do that, can you? Okay, because what happens, it could turn deadly though, couldn't it? Okay, so it's important, it's kind of important for divers, you know, they have a diving watch, don't they? Okay, it tells them depth, and I think it also gives time, doesn't it? Okay, so as they have, once they get to a certain depth, they gotta take so much time to kind of gradually work their way back up. Is everybody clear? So you may run into a problem like this, where you got TD, okay, is equal to 1700 divided by D minus 33, okay? And that's a formula to figure how fast I can come up based on my depth, how far I dive, okay? So that's a practical use for it. I'm sure NASA does, you know, some things like that. Very nice, good.
Okay, so assuming we don't plan on becoming a scuba diver when we grow up, and we just want to be like a pre-K teacher or something, when would we use this?
Probably never.
You know what? You don't know if you're going to be a pre-K teacher. That's why you're learning this. For all you know, you're going to be a mathematician.
Here's the deal. We got 4 sections to do. So in probably a week or 2 weeks, you're going to have to do what? You're going to have to take a test in here. All right? So you're going to have to know for that for sure. So that's where I would start. I can't predict if I'm not saying you won't be a pre-K teacher. Okay?
It's not even just pre-K teachers, just most jobs don't include this.
Architecture probably does.
Yeah, we use a lot of this in electricity.
Electricity, there's all kinds of
I mean,
engineering
it's
fields.
not like it's not like when you're working on the house, so like, how many people, you know, they make some problems where you do that yourself. You're probably right.
We'll get there, Kevin. Just relax.
Wait, are we not gonna do that one before that?
It's Friday.
Yeah, do that one. Sorry. Do that one real quick on your own. Now you know, look at your bottom number. What do you have on the bottom? It's what kind of quadratic trinomial, right? Okay, so you know you should already be thinking in your head, if I factor this, okay, I'm going to end up with how many numbers on the bottom? 2, right? Okay, so look at your answer choices, guys. Can I eliminate some answer choices here?
Yeah, there you go.
I can eliminate A for sure, right? I can eliminate those 2. My answer's got to be what? Okay, so if you just know some basic concepts, right, you can kind of help yourself out a little bit. All right, that's what we tried to be working up to, right? Trying to pull up some of those basic concepts that you guys learned first semester and part of this semester. Okay, kind of helps you. You know, is it good to be able to try to eliminate answer choices on like a test? Oh yeah, big time. You want to increase your odds, right? Okay. All right, do the next one. Let's look at the next one. Now, what do you notice about this one that's different than the ones we just did? Yeah, what else? Can't eliminate anything, but why can I not eliminate anything? How many variables were we working with? Just one, wasn't there? How many variables do you have here? You got two, right? There's an AB here, an A, there's an A there, and there's an AB there, right? Okay. Can I factor still? I mean, do these two terms have something in common that I can factor out of them? Okay, so think about your distributive property. Okay? So I'm going to go A4, write this down on the side. Okay, now look at the first two on the top, these two terms. Do they both have something in common that I can take out? A to the what? And then I'm going to put my parentheses. What do I got to leave? The B. And then the minus. What else? The 2. Okay, what can I take out of these two terms on the bottom? A to the third. And then I'm left with 2 minus B. Everybody with me so far? Okay, so what else can I do? Can I go any further here? Y'all, Riley?
You can take away 3A.
Right. I can do this. There's 3 there, right? How many does that take away from there?
3.
So it makes it a 1, right? Guys, with me so far? I'm going to go ahead and bring my A down. All right, so resolve those, taking care of those. Look what you have left over. It looks similar, but it's not, is it? Yeah, so I can modify either the top or the bottom by simply multiplying by what? No. If I got a positive 2 here, right? What's this? It's a negative 2, isn't it? Well, what if I took this top and I multiplied it by negative 1? It'd give me what I wanted, right? Exactly. So multiply that times, that'd be negative B. That times that would be what? Now, here's the trick. Here's what everybody forgets to do. I multiplied the binomial times negative 1, but what about the A? Because it's still on top also, isn't it? So I got to do what? I got to multiply it times a negative 1 too, right?
I don't know why it's wrote like
I got to multiply it, but I'm going to wait till the very end to do that. I'm going to bring my, can I rearrange these? Can I like turn them around?
Float your boat. Why not?
So now what happens here? What's negative 1 times A? That's it, man. Hey, do that one real quick. Almost done. Okay, what's the answer?
Negative.
Very good. Everybody get something different? Okay. Is there another one on there? Okay, go to your assignment. All right, back page, I want you to go to 24. And that paper that I just gave you, okay, this is number 24 on your assignment. So turn that over. Okay, write these down. Now, listen, guys, this assignment requires what? Work. All right, if you just put the answers down, okay, what am I going to think? There's something fishy, right? You probably just copied the answers from somebody else. That doesn't do you any good. All right? If you finish today's assignment, what can you do? Turn it in and I'll get it graded over the weekend, right? You can start real quick. Any questions about that? Okay. So, I would also, too, you're going to have plenty of time in class today. There's only, how many problems are on there? No, there's not. There's only 12, right? So you guys should be able to get 12 problems done today. I would get it done in class so that you don't have to do what? You don't have to work over the weekend, right? Makes sense, doesn't it? All right. Okay, so let's look at this one. Does anybody know the formula for volume of a cylinder? Right off the top of their head? Okay, write it down. Huh? Okay, that's a square though. You got a round. So what do you got to add in there? So you got to throw pi in there, right? Because you got a circle on there. Okay, because it's round shape, right? Okay. Can I use diameter or radius? Either or? Okay. Or, and then I got to know how tall it is, right? Because does that affect how much volume?
Yeah.
So we got to add height. The volume equals pi radius squared times height. Don't use diameter, okay? And I'll explain why here in just a sec. Use the radius squared, okay? Everybody with me? All right, so I got too many variables here to start out with. I can't really solve it, can I? So can I start replacing these variables with values? Okay, which one can I replace first? I'll just leave it though as a symbol. Okay, that's not really a variable, is it? No, it's not. Okay, here's a variable right here. Is there something I can put in for it? Read the instructions real quick. Because I guarantee you this, you may you're probably, good chance you're probably gonna see one on the ACT like this. Right, so this is, it tells me is essentially the volume, right? Okay, so I can take this and plug it in for the V. I'm gonna rewrite it. Make sure you give yourself some space here. And if you notice, I got a pi sitting out there next to it. What does that equal? Well, it equals
2x plus
the pi.
Oh, that's 3.14.
Yeah, but don't, just hold off, I'll show you why, okay? Don't change it to 3.14, okay? Alright, radius squared. Do I know the radius? I have a value for the radius. What do I have a value for though? The diameter, right? You guys with me? So from here to here is the diameter. Well, where's the radius? It's like halfway in between, right? So what if I just took half of that? Would that give me the radius?
Yeah.
Sure it would. Take 2x plus 6 and divide it by 2. There you go. X plus 3 equals the radius. Okay, if you notice now, you still have what here? Okay, so when I plug this in, I got to use parentheses. Now, how many x plus 3's do I actually have?
2.
Okay. Remember that. And then what do I bring in next? Yeah, we don't know. That's what we're trying to discover, right? But if you notice, what have I done here? I've got it all the way down to how many variables? So I can solve it now, right? How do I solve for h? Can I just start moving some things around? How would I do that, Riley? What if I just divide by pi? What's pi divided by pi? It's 1. It's not nothing, it's 1. But we don't have to write 1 because 1 times anything is just, it's going to be the same thing, right? Okay, so if I do something to one side, got to do it to the other side too. Guys with me? Okay, now, what else can I divide by here? Huh?
X minus, X plus 3.
How many of them though, Crystal? There's 2 of them, right? So I'm going to write it like this. Because then that, I know that tells me, Kendall, why don't you bring me your phone? Since you don't want to listen, you want to text, just bring me your phone. And you can come to lunch detention today. All right? Okay, so at this point, I know that I'm dividing by these 2, right? If I'm dividing, then I know I can write these. I got to write it just like that on the other side. Everybody with me so far? I don't want to lose anybody. Okay, so now, hopefully you're writing this down because it's part of your assignment, DJ. No, you need to write it down. Okay? Everything. I'm going to count it wrong if you don't have it, because that means you just copied off of me. Okay, these cancel out. Can I cancel anything on the left side? I can cancel those 2 pi's out, right? And then 1 here and 1 there. Okay, now, what do you suppose I need to do at this point? Can I cancel anything else out? How do I know, though? I mean, because what do I need to do with this? I need to factor it too, don't I?
Wait, hold on.
I don't flip it. Just factor it.
Hello?
What? So you should have been paying attention instead of
I-
sleeping over there.
I was paying attention.
Nah, you were sleeping.
Okay.
That's why I said something to you.
Sorry, I didn't want to talk about that. But okay. X plus 3, you didn't cancel that one right there. Why you canceled all the other ones?
Give me, can I finish? I'll finish and I bet I answer your question.
Alright.
Okay, so, I still probably need to factor this, don't I? Because I may be able to cancel that out also. But I won't know until I do what with the top.
Gotcha.
Leading coefficient is what?
1.
Okay, so it becomes easy. X, make your tree.
-63.
I mean, do I need to go any further?
So why can't we use the diameter?
Because the diameter is not, essentially it's not factored. You'd have to factor it anyway. You see what I'm saying? You don't know what factor means?
Yeah, I know what factoring is.
Okay, well, that's what I'm saying. You're gonna have to simplify it because it's not gonna look like anything that you're gonna have on here. You see what I'm saying?
Yeah.
Okay. That's why you don't use it. That's why you don't use diameter. Okay? Go ahead and factor it out by taking the radius. Okay? All right, if you get done, turn it in to me later. Make sure that you have that written on your paper. If you don't, I'm not going to give you credit for it.